we will manage all the documents required for the KM submission. So KM submission is the kebenaran merancang with the local authority. So usually we will get the instruction from this local authority to execute the KIE. So then the developer will appoint this traffic consultant to do the traffic impact assessment. And then from that, the traffic engineer will have the discussion with the developer, especially to determine the scope, the study area, and the study methodology for the proposed development. And then we will collect our existing data, information about the study area, and then we will understand about the study area, such as their traffic situation, their the existing condition. And after that, we will start the traffic survey, traffic count. So after we done with the data collection, after we done with the traffic count, we will start the report analysis, which includes the calculation, and we will also run a traffic simulation software to get the result of our level of service of our surrounding road network, the delay of the intersection, and the queues of the vehicle at the intersection, for example. And usually we will receive the kebenaran merancang layout. The layout usually we will get from the planners. And then from this layout, usually we can identify the impact of our development to the existing road network in future. And we will come out with the improvement or any mitigation measures to our client. And then we can form a traffic impact assessment report. So the forming process for our client. The objective that we want to achieve when conducting KIE is we want to determine the existing road and junction characteristics in the study area. So this includes the type of road, the number of lanes, and the type of junction. For example, is it signalized junction or is it unsignalized junction? And sometimes we have 3 junctions, and sometimes we have 4 unjunctions, or sometimes more than that. So we want to analyze, we also want to analyze this existing traffic condition of the study area in terms of its traffic situation system. And then we want to, the objective also, we want to forecast the future traffic generation and attraction for various direction of the study area. So this is to identify the potential traffic impact of the proposed development to the existing road network. And then we also want to investigate the necessity to further improvement to the junction due to the additional generated by our proposed development. And usually we will suggest the improvement necessary to maintain the acceptable junction performance criteria. So how we identify is it the acceptable junction performance criteria is based on our level of service of the road. So the acceptable junction performance usually we consider it as the LOSC to B, but LOSC is still acceptable, but after C like DEF, LOSC and DEF, we will come out with the proposed recommendation or implementation to improve the intersection of the affected intersection of our study area. So let me see first for the data collection. So when we want to do the data collection, first we will start with the site visit. Why? So it is because we need to familiarize with the study area so we can identify the traffic circulation pattern of our proposed development and to identify the workload that will be affected by our proposed development. So from that observation, we will point out each critical intersection that connects the road with our proposed development. And from here, we will select the critical intersection for our traffic study. And this critical intersection is the one that we consider to have the highest use of the vehicles or we see as the live traffic. We consider the highest traffic condition at the surrounding study area, especially at the intersection. So we also need to determine the road type and the number of lanes at the selected intersections, as well as their each indicated flow to prepare the traffic consideration. So, and then we can start after we've done this site visit of the study area, and then we have collected some information for the existing intersection, and we have selected our critical intersection. Let's start with our traffic count. So this is the example on how we identify critical intersections at our study area. So as you can see here, this is our proposed development, the one in the red box with white line here. So this is at Bandar Kuantan Pahang, and from this Bandar Kuantan, we have observed that their traffic circulation is more like one-way circulation. So you can see that the traffic flow from the Jalan Mahkota and Jalan Besar is like one-way in the loop circulation. Meanwhile, as you can see, Jalan Penjara and Jalan Bukit Ubi, they are two-way road, but they have a different number of lanes. So Jalan Penjara, it consists of two-way four-lane road. Meanwhile, the Jalan Ubi, it has two-way two-lane road. So Jalan Penjara, it has four lanes, and Jalan Bukit Ubi is two-lane. So as you can see that Jalan Besar is our main road to access to our development, and it's also the only route for the traffic um, to exit from our development. And this is the only route that generates the traffic flow from our development. So we consider that the Jalan Besar and Jalan Mahkota will be affected by our development traffic. So along this route, we will identify the selected intersection that connects with our proposed development for our study area. So the orange color is the unsignalized junction that is affected by our development in future. So the green color is the signalized intersection, the signalized junction. So in total we have like 8 unsignalized junction and then 2 signalized junction. So we have total 10 selected intersections that we consider affected by our proposed development, so that we want to study for our traffic impact assessment that we want to assess. So after that, after we choose our principal champion, we can start with our traffic count schedule. So usually traffic count will be done by manual or by screen sensor, and we usually will start from 7 a.m. to 7 p.m. This is the common time for people to go out and coming there from work. So this is the time we consider that have the highest traffic volume. And for the screen sensor, most of the time we only use this screen sensor method to get a large amount of traffic data. And this method is mainly used for 24 hours count. And normally we will only use this method at highway because at highway we have large amount of traffic data and the car is moving too fast. So this is very unusual for the human to come. So this method is very common one that we use for the large data at the highway. So throughout the time of the traffic count, the peak hours can be identified by visual survey, and we can also provide by calculation from the calculation letters that we have collected, the data that we have collected. So during the traffic count, we must identify the type of vehicle for each indicated zone. So this is because each vehicle have different number of passenger car limits. So they have their own passenger car limit. So this one we can refer to the highway capacity manual, HCM.9. So later I will show how we convert our raw data that we have collected to the traffic volume according to each type of the vehicle passenger car unit. We need to convert the raw data because we only can use the traffic volume in passenger car unit to run in our traffic software. So later I will show how we convert the raw data to the passenger car unit. So this is the example of what I said before about the indicated direction flow at the intersection. So we will start our count survey or traffic count for the vehicle for each indicated flow. So as you can see in this figure here. So this is one of the example. If I'm not mistaken, this is the signaler junction of our Bandar Pantai just now. So we have two. So this is either one. So as you can see, the approaching lane to the northbound, we have these two indicated flows, which is you can turn left and you can go straight. So during this traffic count, you need to identify each vehicle go through each indicated direction too. So same as the westbound, especially the westbound, you can turn left and turn right, and same to the northbound arm, you can turn right and go straight. So each of these indicated flow is need to be counted, and usually one person will count for one intersection. So after we done with the data collection, now I will explain on how to calculate the traffic volume in passenger car unit, and we will calculate the passenger car unit to the passenger car unit per hour, so PC per hour. and how we operate it. So this is the example of one indicated flow, one indicated direction flow at one junction. So we will convert our raw data that we have collected from traffic survey, and we will convert it to PCU. So as you can see, this table, this is from the Excel, the raw data that we collected. So for the vehicles, for the car, we will punch this 1.0 unit. And for the motorcycle, the percentage unit is 0.33. And for the light lorry and van, it is 1.75 in PCU unit. And for the heavy lorry and buses, the PCU unit is 2.25. So this each vehicle have different percentage unit. So you can refer this to the arahan teknik jalan guidelines on geometric design approach to get the percentage unit. So from this percentage unit, we can get our PCU per hour. And how to get it? We can identify it by cumulative 4 cycles for each 50 minutes of our data collected. So as you can see here, we collect our data for every 15 minutes. So 7 to 7:15, 7:15 to 7:15. So it shows that we collect our data for every 15 minutes. And then to convert it to the hour, we will do the cumulative additional for 4 cycles of the 15 minutes. So it completes the 1 hour of the PCU traffic volume. So after we can calculate the PCU per hour for each indicated flow. For example, this is the example that we've done for each indicated flow. This one I choose for junction 1. This is the example for one junction only. So as you can see, this is the example. And then after we get our PCU per hour for every each indicated direction flow, we will add the PCU per hour. As you can see in the red circle there, that is the each of the PCU per hour that we have calculated. And from that, can get the total volume of the PCU per hour for this junction, for this one junction. And this total volume of the PCU per hour we can get it by adding each of the junction of the PCU per hour, and we will get the PCU per hour for the all junction. And so from here, as you can see, the blue circle there, that is the total PCU per hour for all junctions. And so we can identify the peak hour volume during AM and PM by choosing the highest value of the PCU per hour for all junctions. So as you can see, the one that I circled in the blue line is the highest volume for all junctions. So from here we know our AM peak hour and also PM peak hour. So this is the example during PM peak hour. So the AM peak hour, you can see it is the highest volume of the PCU per hour for the all junction. At the blue circle there. So for this indicated flow, as you can see, after we get our highest volume of all junction, we can identify our AMP hour, which is um, 7:45. So it is 8. Sorry, I cannot see for myself actually. So this is the blue line is our AMP hour and PMP hour. So from that we can identify um, our PCU per hour for each indicated flow. So this is how we get our PCU per hour for this junction, for one junction. So now from the PCU per hour that we got for one junction just now, we can use it for the traffic simulation software. For our KI, usually we will use Sidra, which is the most affordable and the most common one. But now we also use the listen. I'm sure that everyone is already know about Sidra. So the performance of the existing junction can be analyzed using Sidra, and Sidra is actually um, a software that has been developed by Australian Road Research Board, and this is one of the software that, that also can be used for the unsignalized intersection. And I will explain generally how to use the Sidra. So first, you will choose your type of junction and how many lanes for each opportunity for each arm, and then you will enter the volume that you have before, that you have calculated before, which is the PCU per hour. And then after that you can just enter your you can run your Sidra for each junction, but then you need to adjust your lane movement, your geometry of the road, and you will get this result after you run your Sidra. So this is the example of the result after you run your Sidra. So from this Sidra, you can get your level of service, the degree of saturation, the average delay, and the choice of the vehicle, and the effective stop rate, the average number of cycles, and the average speed. So this is the common one. But in the traffic impact assessment, usually we will focus on the level of service and their average delay, as well as their use of vehicles and the degree of the separation of each indicated lane. So this is the result that you will get after you run the Sidra. Um, so the road performance usually measured based on the volume to capacity, volume to capacity ratio, which is it is related to the level of service and concept, where the level of service A and F represent the best and the worst operating of the road respectively. So this one can refer to the highway capacity manual or the rim guidelines to identify the volume to capacity ratio for each junction. So this is based on the rim guidelines. So as you can see in this table, LOSE is indicate the junction is in the free flow with low volume, and LOSP is a stable flow with slight delay. And CLOSC is also considered as the stable flow with acceptable delay. So that's why in PRA the ROSC, we still consider it as the acceptable delay. But when we start with the ROSC, it start approaching the after the pole, but still with the tolerable delay. And sometimes when in the busiest route, such as in Kuala Lumpur, sometimes we still consider ROSC for our road network. But usually we will give the recommendation or the um, the recommendation to improve the road network usually after we got the LOS, E and F, which means it's start operating at the unstable field. And we will maintain the junction performance criteria if only it have LOS A and B usually. So from the existing traffic data that we have collected, we can develop this future traffic forecast to predict the future traffic condition. So the future traffic forecast can be identified by applying 10 years projection after development is done. So for KIE, we will use 10 years projection, and this one we can refer to the arahan teknik jalan part 9. So this one, the changes of population growth actually depends on the route path that we use, which we call it the station. So it's stated in the RTBM guidelines. So we can refer to the RTBM guidelines. Every development has different percentage of use. So this one we can um, refer to the RTM guidelines, but these RTM guidelines, they have a different number of statistics or issues, so they always update their guidelines. So you need to refer for the updated one. For example, we are in 2021, maybe we can use the RTBM guidelines for last year, which is um, not really give much difference. But you cannot use, for example, especially during this pandemic, the RTBM, for example, RTBM 2019 or 18, it will give different number of statistics of the population growth. So you cannot use it, the, the, the previous RTBM. So you need to use the updated one. So for example, Bandar Kuantan, this is the example for the Bandar Kuantan. This one is the RTBM, the old RTBM. I think this is the building. Okay. So, just now, the proposed development is at Bandar Kuantan. So this Bandar Kuantan, you can see the road that can be accessed to go to our development. So for this proposed development, we use the Kuantan Maran Road. So this Kuantan Maran Road is actually at the station CR404. So we need to refer to the station at this RTBM guidelines. So this CR404, it will give the percentage growth of this route, which here you can see the CR404, the percentage population growth is 3.4%. So we will use this percentage to find with the current traffic data that we have collected before, and then we can get our future traffic forecast to predict the future of the traffic generation. So this is the example for the future traffic forecast. And from this, we can use the data to predict the future traffic condition for our development. So on the left is the example of the future traffic forecast that we have developed for 10 years projection. So on the right is the future traffic forecast with our development traffic. So you can see there is a difference. First, we just developed the future traffic forecast, but the right side is the future traffic forecast include our development traffic. So as you can see that our development traffic will generate some traffic and will might affect the road network in future. So the proposed development will impact the traffic at the study area after it completed, and the calculation for the the traffic generated from our development. We can refer this in traffic in the trip generation number guideline. So this is the example of our proposed development in Kuantan Pahang, Bandar Kuantan. So usually it will produce the trip generation both ingress and egress, which is in the traffic entering the development and also the traffic exit the development. So it depends on the type of development that we want to do. So this will attract and produce more traffic, and from these trips, the main focus is determining the traffic impact in future. So this one you can refer to the trip generation manual guideline. I would like to show the example. So this is the example of the calculation. The traffic attract and produced by our development, it consists of development of apartment, retail shop, commercial, and hotel, as you can see here. So every type of this component has their own trip rates and their own PCU and percentage in and out, which you can get from the trip generation manual guidelines. And for the variance type, as you can see, the variance types at the column is after the percentage out is this will be provided by our planner, and this will be stated at the kebenaran merancang layout, which is the KM layout, which I will show the example later. And the trip rates to get the percentage, to get the volume of our proposed development, we need to punch our trip rates, and then we need to punch with the PCU, and then we punch with the percentage in and the percentage out, as well as its variance for the each type of the development. And then we will get the traffic attracted by this development and traffic produced by the development. And this is how we calculate our traffic development. And this is how we produce traffic development and the traffic produced and attract during the AM and PM peak hours. So this amount of ingress and egress of the development will be added to the future traffic forecast for the 10 years projection. So as the prediction of the future traffic condition after the development completed. So this is the example of the KM layout. Just now we don't know where to get the variance type. So this is where we get the variance type. For example, we will get the number of unit apartment and number of room hotel and the basement area for the commercial retail shop. how big the commercial is, like what is the square meter of the commercial. And this usually will be provided by the planner. And this also depends on our type of development. For example, if we want to build a school or institution, we're going to have different number of variance type. So the variance will be different. So the level of service produced from the development, it is necessary to maintain with the acceptable jumping performance, usually LOST to C. So as the conclusion for the KIE, the necessity to further improvement and mitigation measures to the study area will be due to the additional food generated by the proposed development, and it will need to be considered. And especially with the junction performance criteria of the LOST to F, this need to be considered. It is to ensure that the road network can be safely accommodate a proposed development and to minimize the impact of the future traffic conditions. I think that's all for me. Thank you for listening. Actually, I want to share the example of the RTBM. So, this is the example of RTBM 2017. Usually, it's quite hard to get the access to this RTBM, the road traffic management, because it always updated for every year, and to get the access, sometimes we don't know the source to get the access, and sometimes we need to buy it from someone who can access this RTBM. So this one really not cool, but it has the example. So this is the example at the Kedah. So as you can see, the Kedah, it has their own station number. So this is the station number, which indicates what is your main route that you will use to access to your development. So from here, you can get your percentage boost for your main access route. So this is another example. So this one, you need to get the access for this. So thank you. I think that's all for me. If you have any question, you can ask now.
Terima kasih kepada Engineer Siti Masina Maksud for a very nice presentation. Actually, apa yang Engineer Siti Masina present tadi dah sebenarnya cover for the whole lah. The initial step of what we going to do with the traffic impact assessment kan, sampai pada awal sampai siap lah. Itu secara basic lah. So kalau sekarang ni saya buka lah kepada Q&A. Kalau ada soalan boleh tanya lah. You can ask Engineer Siti Masina directly lah. Sebab sebenarnya untuk makluman semua, ini kita akan gunakan, knowledge ni kita akan gunakan pada tahun 4 nanti untuk first part of you punya IDP, Integrated Design Project, yang mana kamu akan buat laporan Traffic Impact Assessment. So kalau ada soalan, saya ingat inilah masanya untuk kita ambil kesempatan lah untuk tanya kepada jurutera lah apa yang perlu, apa yang tak perlu lah untuk apa dalam preparation apa report apa benda kan. So boleh tanyalah, boleh apa unmute and then ask the questions directly to the speaker.
But just now, saya baru press untuk dapat segmen tak berapa dengar.
Sorry, tak dengar lah pasal.
Tidak, saya baru baca doktor cakap mic saya tak berapa dengar. Jadi,
Tak apa. Ada soalan? Boleh tanya teruslah kepada speaker. Mungkin saya ambil 2-3 soalan lah. Kita akan berhenti pada pukul 11, 2-3 minit macam tu lah.
that jadi sesuatu yang second buat macam kita ni dia ada WhatsApp page, so boleh lah kalau nak tanya ataupun tanya dekat group Microsoft Teams dia akan soalan saya akan
Dia pelajar-pelajar tahun 3 ni dia pemalu sikit.
kalau last yang macam before this favorite dia orang pun tanya after that, but dia orang tanya to WhatsApp and ada yang tanya dekat Microsoft Teams punya group letter insyaAllah saya pergi
Dekat Microsoft Teams, saya tak perasan.
yang group before this.
Oh. Okay, ada soalan? Tak ada? Kalau tak ada soalan, saya ada 2-3 soalan lah saya nak tanya engineer speaker kita ni. Katakan dalam satu kawasan tu kita nak buat TIA lah kan. Apa radius yang sesuai untuk kita ambil tadilah, kalau macam yang Siti tunjuk tadi dalam kawasan yang contoh yang tadi yang dekat Kuantan tu kita ada macam 8 unsignalized junction dan dua untuk signalized junction kan. Untuk kita tentukan area tu, macam mana kita selalunya jurutera tentukan area tu? Kenapa kita macam tadi contoh kes tadi kita ambil 6 dengan 2? Kenapa, ataupun maksud saya apa radius yang sesuai untuk kita ambil consider dalam kita punya TIA study ni lah?
Sebenarnya kepada kita punya development, untuk macam tadi dia punya dari dia punya konten, dia punya traffic sebenarnya dari kita punya development tu tak berapa banyak kalau kita compare dengan development besar kan. So selalunya kita akan ambil first intersection yang kita punya traffic daripada development kita akan lalu. So first intersection selalunya kita ambil sampai dulu daripada keluar daripada intersection yang kita akan lalu. So macam within that radius, the intersection yang affected daripada kita punya development, yang mana dia akan lalu. So the first existing kita punya development punya intersection tu, kita consider that is the first critical junction for our development. Menjawab tak tak?
Okay. Soalan kedua saya tadi biasanya kalau dalam TIA ni kita akan buat projection untuk 10 tahun kan, 10 years punya projection, betul? Itu saya tertanya-tanya jugalah, kenapa 10, kenapa tak 15 ke, kenapa tak 20? Dia bukan macam kalau 10 tahun ni dia agak cepat ke? Tak tahulah, ini saya nak tanya je ni.
Betul juga doktor sebab kita orang selalu juga ditanyakan soalan ni dengan level authority kenapa 10 tahun, tapi selalunya dalam masa 10 tahun ni pun akan ada satu tempatan lain yang akan conduct CIA juga dekat area kawasan yang sama. So, 10 tahun sebenarnya just under A3 kat 6 untuk development tertentu lah. For example, kalau masuk MRT ke macam projek besar macam railway, selalunya dia akan guna lagi lama lah, 15 tahun sebab data collection dia semua lama boleh guna. Kalau masa KIA ni semua 10 tahun. Maknanya kita punya KIA tu orang lain ada satu persatu nak guna as reference, boleh kita guna lah within 10 years. Tapi kenapa 10 years tu actually bergantung pada development kita. Kalau macam MRT, dia punya projection tu lagi lama lah. This one yang kita boleh refer daripada aeronautic itu.
Okay. Apa ni, saya nak tanya soalan yang ketiga saya lah. Apa ni, dia kalau TIA ni, dia punya method ni adakah dia akan sama untuk katakan apa ni, jalan JKR, expressway, highway, dia punya method sama ke ataupun ada perbezaan? Sebab apa ni, kalau dalam kelas pelajar ni dia ada belajar lah tentang apa freeway, expressway. So akhirnya adakah kita akan gunakan teknik yang sama untuk kita lakukan apa TIA study ni untuk jalan yang berbeza lah?
Selalunya kalau dari segi jalan tu selalunya dia kurang sama, tapi dia ada juga beza dia. Contoh macam kalau kita buat TMC, prosedur dia nampak sama, tapi sebenarnya dia ada dah additional prosedur dia. Contoh macam kalau highway kan, kita nak buat construction, kita akan add dia punya safety issue buat kita conduct kita punya report. Saya rasa yang berbeza sikit lah kalau highway.
Okay. Soalan last daripada saya lah. Tadi apa ni, Engineer Siti Masna ada tunjukkan apa ni traffic growth tadi kan, percentage of traffic growth untuk sesuatu kawasan lah. Let's say katakan dalam satu kawasan tu kita tak ada dia punya percentage tu, kita macam mana kita nak buat?
Kita tengok dia nearest selalunya. Kalau kalau tak ada jalan, kalau kita tengok dia nearest jalan berdekatan yang antara yang paling dekat lah.
Okay.
Kita ambil dia punya percentage tu sebab actually dia dalam radius yang dekat lah dengan kita punya property development.
Okay. Itu saya nak tanya lah. Okay, so ada soalan lagi? Saya buka last question. Sebab nanti semasa depan ni kamu nak kena belajar dengan apa ni, sidra, nak gunakan untuk analisis, untuk buat report semua. Itu nak kena tu lah. So kalau ada suatu soalan, sebelum saya tutup.
Maaf nak tanya. Hello?
Ya, sila.
Contohnya kalau kita design, kalau dia macam ada perubahan di sesuatu kawasan tu, dia ada macam at first kita design sebanyak ini kenderaan dia berlalu, tapi selepas mungkin ada perubahan di tempat kawasan tu, dia menyebabkan penambahan kenderaan tu. So maksudnya nanti kita akan design semula ke pada masa akan datang ke atau macam mana?
Selalunya kita punya KIA ni, bila kita nampak our study area tu ada construction kan, selalunya kita akan dapatkan traffic daripada yang produce daripada development tu. So kita akan add in our report. Terus kita akan add terus as a proposed as a affected traffic from other development, surrounding development. Saya tidak akan add dulu sebab kita tahu yang dekat area kawasan tu ada few development ongoing construction.
Dia maksudnya kat sini siapa yang mulakan development awal kat situ dia akan rugi lah. Macam mana?
Selalunya tak tahu pendapat saya lah. Saya rasa selalunya orang yang develop after that yang rugi. Sebab saya pernah ada satu development dekat area Pisau Kiara. Dia banyak tanah tu, banyak NASA company. Saya tahu NASA yang one of the richest juga lah, seorang di dekat Malaysia ni. Jadi dekat situ dia dah banyak construct dia punya company, banyak tanah dia dah start construct dulu. This is few years ago, dah lama lah. Jadi dia punya development tu masih lama, masih generate banyak traffic. Tapi disebabkan dulu masih dia construct, kawasan tu tak ada banyak development lagi. So after that, itu macam sekarang ni, orang yang baru nak develop tu kena tanggung beban traffic dia. So selalunya orang yang baru nak develop tu yang kita akan suggest recommendation untuk di-improve jalan tu. Sedangkan dia punya development tu kena ikut traffic. Tapi orang yang dekat area situ yang generate banyak, yang dah generate lebih banyak. Dia dah terukkan dulu jalan tu. Tapi itu pendapat saya lah.
Betul lah tu. Saya faham. Maksudnya dia, kalau secara kasarnya kita nampak orang yang awal lah rugi, tapi sebenarnya tak jugalah. Mungkin orang yang akhir tu bukan jadi paling rugi lah.
Macam kesian juga sebab selalu klien dia tak akan invest banyak kan. Kalau boleh dia tak nak invest banyak dan dia boleh nampak yang dia development tak generate banyak traffic pun. Memang jalan tu dah memang teruk, tapi dia sebabkan dia akan edit more traffic dekat kawasan tu. So dia kena come out with the mitigation measure. So dia kena invest sikit untuk reduce the traffic.
Okay, so saya ingat kita dah 11:10 pagi. Saya ingat kita boleh berhentilah dekat sini. Thank you very much. Terima kasih banyak kepada Engineer Siti Maslina for a very interesting sharing session dengan pelajar semua lah. So hopefully semua pelajar boleh faham dengan apa penerangan daripada kita punya speaker ini. As I said before, benda ni nanti kita akan pakai untuk IDP IDP pada semester 1 tahun 4 nanti. Okay, kalau tak ada apa-apa, before we adjourn our class, jangan lupa minggu depan kita ada satu lagi kelas akhir untuk flexible dengan rigid pavement. Yang ni saya harap semua orang dapat hadir sebab dua-dua topik ni akan masuk dalam final exam.